Okay, welcome back to this course on deep learning for advanced vision systems. Now we're going to have a look at the multi-layer perceptron and the backpropagation training algorithm. So before we look at what is the multi-layer perceptron, we just refresh our memory about what is a perceptron. So as you recall, so it's a kind of a node, just a neuron, and it has an input pattern, x1 till xm here, the corresponding weight. So you have a junction, a summing junction here, which gives you the activation Vk, which is given by this formula, is the sum of Wkj xj plus bk. So this is for node k. And so it is x1 wk1 plus x2 wk2 up to xm wkm. And then we add a bias here. So this activation, this net activation, is fed to an activation function, phi, which is, in the case of a discrete perceptron, given by the sine function, and in the case of a continuous perceptron is an S-shaped function, a sigmoid, as we're going to see in the next slide. And the output, yk, for this node k, is simply phi of vk. So your input to this activation function is the net activation. Now we may have used a different notation before, so the wkj, meaning that k, the first subscript, correspond to the node vk, to the node k, sorry. And then the j is from 1 till m in this case for this input pattern. So the two types of activation functions, so we have the sine function or the signum function for the case of the discrete perceptron, which is in the bipolar case goes from -1 to +1, meaning that the output here can be either +1 or -1. And in the case of a continuous perceptron, it's this S shape, looks like an S function, which is again bipolar between +1 and -1. Now, what is the multi-layer perceptron? The multi-layer perceptron, so it's a perceptron, you have the word perceptron here, and it's a number of layers, multi-layer. So it was introduced in 1961, a while ago, and it's a feed-forward type of network, not a recurrent one. So you have the input signal here, or the input pattern is fed to the input layer, and then you have a hidden layer and your output layer. So you have multi-layer. So in this case, it's just one layer, one hidden layer. And then the input pattern. So you have here at this node, at this node. So it is, you have the input from this input node. You have the input from this input node, and then also from this one. And then again, this is simply a perceptron where you sum your input with the weight, the corresponding weight, this one, and this one. You have a net activation, which is fed to an activation function. And then that gives you the output, which is fed again to the next layer. Okay, so you have one input layer, one or more hidden layers. In this case, it's just one, and one output layer. And learning is a supervised learning, meaning that you have a supervisor here, which gives you the desired output. You feed the input pattern, and then it gives you the actual output. This is compared to the desired output. And then we're going to see the backpropagation, how the backpropagation works to adapt or to adjust the weights. So first, some terminology or conventions. The arrows indicate the direction of the data flow. So the data flow goes from here to here to here and so on. The first layer termed input layer just contains the input vector, does not perform any computation, so you don't have any computations here. The second layer termed hidden layer receives an output from the input layer, as we explained before, and sends its output to the output layer. So it sends it to the output layer, in this case where you have just one hidden layer. After applying their activation function, the neurons in the output layer give you the output. So again, this is this neuron, output neuron receives the input from this node and this node, this hidden node and this hidden node, and then it sums the output here with the weight, the corresponding weight, sums the output with the corresponding weight. So you have the net activation, which is, again, you have, because this is a perceptron, so you have one of the an activation function, and then you have your output, okay? And then you have an output vector here. You have an output vector because you have a number of nodes here. So why? Now we've seen what is a multi-layer perceptron. We want to understand why we are using a multi-layer perceptron. We've seen that the single-layer perceptron classifier, which we discussed before, can only deal with linearly separable set of patterns. Now, most of the cases, we want to do more than that. For example, in the case of the XOR functions, so the multi-layer networks, which would be introduced here, and which are one of the most widespread neural network architectures. Actually, they did very well up till at some stage where there was no lack of an efficient training algorithm to deal with when you have, for example, a number 3 or 4 layers or so. So in that case, I mean, the neural network community was lucky to have the introduction of the backpropagation training algorithm. So again, just to remind you that a single layer cannot solve this problem here. Sorry, can solve simple, cannot solve this problem here, which is the XOR, okay? It gives you just this is the most general regional shape, which is a linear one. We want a multi-layer perceptron, with a number of layers, hopefully, to be able to have a fine classification of our feature space. Thank you.